This episode is sponsored by the IoT Job Site, the world's only dedicated space for applying for and advertising IoT vacancies across the world. Register now for job alerts or get in touch via let's talk at theiotjobsite.com.
Welcome to the IoT podcast show. I'm your host, Tom White. Before we get into it today, please subscribe, comment and share the podcast. Your support really helps us and we appreciate it. Today we are joined by Dean Nelson. Dean is the CEO of Virtual Power Systems and the founder and chairman of the trade group Infrastructure Masons. Dean, welcome to the IoT podcast show.
Thanks for having me on, Tom.
You're very welcome. For some of our listeners, Dean is a strategic advisor to the Autonomy Institute that you may have remembered came on with Jeffrey Decoux and also partnered with EdgeX. That was a free person podcast that we had on in the past, and James Thomason through Dean's other business, VPS, which is Virtual Power Systems, which is looking to harness and enable the connectivity when it comes to power to the Internet of Things. We've been waiting to have Dean on the show and very much looking forward to him talking a little bit more about his role there, a bit more about VPS and digital infrastructure as a whole. Dean, just to jump straight into it, can you talk a little bit about your background then in building digital infrastructure portfolios and how it is you came into this industry?
Yeah. I've been doing this for 31 years. It kind of blows my mind that it's been that long. I feel old now. I actually started at Sun Microsystems. I don't know if you remember them back in the day.
I do.
On my 21st birthday.
Oh, wow. Okay.
And I started on the manufacturing line. I did 17 years at that company. I feel like I went to the University of Sun. And 2 different stints. I went to a startup in the middle called the Allegro Networks. 3 years right in the middle of the dot-com bubble burst. And had a lot of fun there. Then I came back to eBay, right? So that was the second stint. And then I left when Oracle acquired them. And I did a ton of stuff within Sun. I had started in manufacturing, went to engineering, IT, and then ending in real estate, which is always, everyone kind of wonders, how does that work? Well, the real estate team owned the actual dollars. And the portfolio, and so we were able to drive a multi-billion-dollar, consolidation project globally in data centers and edge infrastructure, even back then. So it was a really cool experience. Then I went to eBay. I spent 7 years there, doing global foundation services. So think of everything at the operating system down: data centers, hardware, and network. Right, the supply chain orchestration of the actual budget, planning, all those types of things. And so we really built kind of metal as a service at eBay for eBay's portfolio of companies. So that was PayPal, StubHub, etc. All the different entities that they acquired over the years, and then did the split of eBay and PayPal, which was very fun, and then left and I took a 6 months break and went to help my daughter find colleges, which is really neat in the middle. And then I joined Uber and did that rocket ship for 3 years, and incredible. We should talk about that too. But then I left and started doing the strategic advisory work. That's where I got to connect back in with the Autonomy Institute, with EdgeX, et cetera, and also with Virtual Power Systems, which I'm now the CEO of. And I had stepped into the board, started looking at the opportunity, and realized that this is just such an untapped element within the digital infrastructure space. It's the next step. We have to bring software defined to data centers, which software is just not part of the core data centers when it comes down to how, I guess, just the mentality of it is very physical in data centers. And so being able to have a logical software solution that orchestrates things is a little foreign, and that's what we're bringing to it, is we're unlocking stranded capacity inside of data centers. And the other side of this is that we're doing this both at the core data centers and at the edge. And everything is about how do you orchestrate the elements to make sure that you've got the maximum amount of utilization out of that capacity you're building. And especially at the edge, it starts to get expensive. It also is many, many more times bigger than it comes down to the amount of locations. And the numbers, of course, you've heard on the other streams and things here. The fact that we're going to get to over 130 billion things by 2028 is what I understand. There's going to be 1 trillion sensors behind them. And then half the data that's generated and consumed is going to be at the edge and dropped at the edge. Right? So there's just this massive amount of stuff coming out. Well, the orchestration becomes even more important. So think back before we had virtualization, right? Dedicated servers, dedicated network, dedicated storage. Well, we have dedicated power in data centers today. And that's what we're actually orchestrating now is to treat it like another asset that can be flexible and can be optimized. So that's a quick summary.
Yeah. I mean, thank you so much. It's a great summary, and I think you're absolutely right. The software element of this, when you talk about data centers, is often overlooked and just something that has kind of been put on the back burner. For our listeners who maybe aren't that akin with digital infrastructure, why does digital infrastructure matter, and what is driving this demand, and has COVID also accelerated this?
Yeah, well, I have a 23-year-old daughter, right? And she streams on Twitch. She does a whole bunch of entertainment stuff. Like she's all in it. And she's been around me for years talking about digital infrastructure, data centers, hardware, network, all the elements that make up that foundation. And so she understands a little bit more. But even her, you don't really realize the dependency you have on digital infrastructure. Literally almost every person on the planet. How you pay for things, how you buy things, right? How you schedule transportation. I mean, everything in your day. Just think about when you touch digital infrastructure. It's whenever you pick up that phone or any other device to do something that's connected on a network, goes through digital infrastructure. So I'll give you a few numbers on this. Today there are 7 million data centers. Okay? They consume between 35 to 50 gigawatts of power. That's about 2% of the global grid today. Okay? Last year, we generated 64 zettabytes of data. Now, a zettabyte, it's a little unfathomable when it comes down to the amount of zeros at the end of that number. Okay,
many zeros.
Lots of zeros. I forgot what total, but it's like 26 or something. So but we're going to be doing 225 zettabytes a year by 2025. Okay, there's a massive amount of data that's being generated, and all that data needs to be processed in some way. And remember what I said earlier, we've got 130 coming up to 130 billion things in the next 7 years. Things. So that's your devices, everything from the phone to the stuff that's at your house. All those things are going to be connected to the internet, and then behind them there's 1 trillion sensors. All of those are generating data, even though the little bitty sensors, all the way down to the grain of a sand for RFID. Like those sensors are going to generate data that needs to be processed in some way. And then when you think of things like 5G, it's the big buzzword everybody talks about, but there really is a transformational thing that's going to happen with 5G. And that is that today we've got a 1-lane freeway. Okay? That 1-lane freeway allows you to get a certain amount of distance traveled at a certain speed. 5G takes that and says, I can now have 100 lanes. So from a bandwidth standpoint, I suddenly have increased it 100-fold. And then it is 10 times faster. That means I can go from California to New York 10 times faster because latency is reduced. Okay, and then there's also 10 times the amount of concurrently connected devices. So those 3 factors suddenly lead to this massive increase in data generation, data processing, right? Data consumption.
100%, and it's such an articulate way of saying it. The sheer volume is unfathomable, really, isn't it? Compared to where we've been to where we're going. And I think given your 31 years in this industry, you're a prime person to be talking about this. With the advent of 5G, people are talking about potential 6G coming out as well. It's just like, how are we gonna manage this? How are we gonna do this? How are we gonna put the infrastructure in place? And I think that's really, really critical, and that's hopefully what we're gonna get right into in this podcast. To going back to your career, and so throughout your 30-year career, you've driven, something like over 10 billion infrastructure projects across 3 different continents. Absolutely huge. Can you talk about a couple of those for us, Dean?
Yeah, I mean, it sounds huge, but what's funny is I'm dwarfed by a lot of my peers in the industry. You put zeros on the end of those numbers. So Google, Facebook, Microsoft, Apple, Amazon, like you think about the infrastructure that's rolled out to do companies like that and the individuals that are actually leading those things. So I'm proud of driving $10 billion worth of projects across the world. But it's interesting because you think about it, the bulk of them are at 3 companies. So I did probably $2 billion worth of stuff at Sun. Okay, so it's like the first 20 years was $2 billion, right? and then I did about, I think, $5+ billion at eBay, because we build out data centers, hardware all over the place, networks. Just you think of all the reoccurring expenses that happen. Okay, and so whether it's capital, OpEx, et cetera, that's where that was coming from. And then I did about $3 billion worth of stuff over at Uber within 3 years. So we're spending tons and tons of money to go back and build out to keep ahead of the demand. That was the key. It was all about making sure you had the infrastructure in the right place. And I had a lot of really cool projects over the years. And look, for me, I've been a tinkerer my entire life, so I was the kid that cut off the plug in the actual light, on the lamp and wired it into a radio from a car and plugged it into the wall, and it blew up and lit on fire and things, and I was like, what the heck? How did that happen, So I've been doing that a long time, and so I try to take a lot of these projects and think about, are we making assumptions and limiting ourselves? And so a few of the really fun projects we did at eBay was we did modular data centers on the roof in Phoenix, and we got the most efficient deployments in the world at that point. We had megawatt containers that are getting PUEs, and it's power usage effectiveness. It's basically how much power is used to do the compute to the actual work and how much is used for everything else. And we had PUEs of 1.018, which is like 98% of the power was going to the compute to do useful work, and the rest of it, right, extremely efficient. And it's 120 Fahrenheit outside, and we're using outside air to do it.
How did you achieve that?
This is taking a systems philosophy. So we basically would bring all the teams together, the compute, the actual facilities elements of it, and then the software orchestration to make sure that it runs as a system. So I've got the workload, I've got the inlet temps, I've got the fans, I've got all the elements that are now balancing. And so we could take outside air at 120 Fahrenheit. We could use adiabatic cooling to basically evaporate the heat away because it's a dry environment in Arizona. And then we would bring 83 degrees Fahrenheit into the inlet of the servers. We'd have a 40-degree delta T. And so the exit temperature was fine, but the equipment's already built for this. So we just tuned it like an ecosystem. And then you get maximum efficiency out of it.
I mean, it's incredible, some of those stories about the efficiency and the size, right, of data centers. I mean, for me and for other people around, we've heard stories about data centers ended up in various locations, right? People dropping them in the ocean, etc. Could you explain why that is? Is it just purely a space thing? Is it a cooling? What's the idea behind some of these weird and wacky places that we're seeing data centers popping up right now?
So I'm going to give you three different categories on that one. First is that you've got the core that is built, and that is all around fiber. So think about just like the electrical infrastructure, you've got generation and distribution of that electrical infrastructure. The network is very similar. So I need to make sure I've got my hubs, these carrier hotels where everything terminates. So 1 Wilshire, 60 Hudson, like you know exactly where these big hubs of the internet are around the world. And from there, they all go out. All these fiber connections go out to all these different locations. So people tap into that infrastructure. So when you talk about the information superhighway, it literally is the fiber paths. And that's along the railroads, that's along the electrical lines. It's, they're trenched all over the place.
Et cetera.
And even freeways. So they're basically connecting everything that way. So from a core standpoint, the people select data center locations based on the concentration of network, right? Available power, cheap power, tax incentives. Like there's a whole selection from that. So that's the first category. The second is that we've got these. I guess they're changing now from an edge standpoint. The carrier hotels are really, really critical, but there's new technology, CBRS, right, that is going to come out and now circumvent even that. People are going to be able to have their own private 5G, right, networks. They're going to be able to now route around those elements when it comes down to how that's done. And so that means that now you can have data centers everywhere. The edge, the Autonomy Institute, where we're talking about pins, the public infrastructure network nodes are going to be in every street corner. So all of that is going to now push the compute and storage and other elements closer and closer to the user. And that user and the machines are going to actually be able to do things extremely fast. Hence the 5G, 10 times faster, 100 more lanes, right? More bandwidth, those types of things. So that changes that behavior. Then you think about the third category, which is the really disruptive stuff. And this is like what Microsoft and even SpaceX and others are doing. They're challenging the way things are done. So you heard those submarine data centers that Microsoft put out?
Mm-hmm. Yeah.
They're just looking for different ways, because you can land those in the ocean. You're tapping into fiber because the subsea cables are everywhere. That's one of the most fascinating things. If people want to look at kind of behind the curtain, go just search subsea on YouTube and watch. They're basically big, long, tethered fiber cables, bundles of these things under every ocean, connecting every continent, right at the edge on the beach into these landing stations. And that goes back to the core data centers, et cetera. So that's one. And then you think about terrestrial today is that way. But now when you think of what's going on with SpaceX and what Jeff Bezos and everybody is doing is now putting lasers in space. Sounds like a sci-fi movie. But you can traverse the globe even faster now because you have no obstructions. You don't have to go over the ether to hit a fiber that goes down and gets a repeater, hits a subsea cable, goes across the ocean, etc. Like you literally can just go satellite to satellite, vroom, and you suddenly circumvent all the other elements. I can now go all across the globe very quickly, but also going down. I can now serve areas across the world that don't have connectivity. How do you get across the Sahara? You get a trench across the Sahara? Fiber? Like, very, very difficult. So suddenly you start doing it in the other direction. So that's what I mean. The third category are the people that are rethinking what the future is going to look like when it comes down to how connectivity is done, how compute is done, right? Processing is going to be done. And so it's a really exciting time in our industry when it comes down to the demand, and then, of course, the technologies and the innovative thinkers that are going after these things to keep ahead of that demand.
Yeah, I mean, it's incredible, isn't it? It sounds like modern-day Moonraker, doesn't it? You know, with lasers
in
space. But yeah, I get it. You know, it's it's an inevitable progressionary point. You know, you challenge what's already been done. How can we make it more efficient? How can we do this? And I think the Sahara analogy is a perfect one. I mean, one of the most hostile places on the earth. You know, how are you going to do that? What are the possibilities? And of course, that's the simplest and the one that's known to man right now. You touched upon something there which I wanted to talk about, Dean, which was obviously the Public Infrastructure Network Node Initiative, PIN, right? So as I started the episode, we had EdgeX and the Autonomy Institute on fairly recently. Can we touch on that a little bit more? So how can we innovate and enable sustainable intelligent communities like PIN and drive these initiatives to the forefront, right? Because I think this is a really important thing to talk about. The guys are talking about it a little bit more, but I'm interested to know from your perspective and that of VPS as well.
So, all right, let me see how I can break this down. So a public infrastructure network node is meant to get compute and sensors closer to the users. And so, think of it as a light pole, that base station that's got compute in it. So number of servers, it's up to 20 kilowatts worth of compute power within that base. And then you've got the mast. And that mast has got all the different sensors, 5G, LiDAR, radar, weather, all types of things that are needed. And it's built to weave itself into the actual landscape. Because right now, the technology blight of the 5G towers and everything else, and needing, by the way, 10 times more towers to provide 5G capabilities, people are not going to want that in their neighborhood. So this PIN infrastructure, I think, is really critical for multiple reasons. So we start rolling those back out. They go and land on every street corner. They can literally be you won't notice that they're there, right? They're woven in. Then that allows you to say every street corner's got these things. Then they connect to these vaults. And those vaults are going to be energy storage, interconnectivity, electricity, water, other things that are needed, and they're going to serve multiple pins, just like you have kind of core data centers that are serving multiple locations. So then you also have EV charging stations that are going to be going all over. So the Biden administration's push on investing in electrical infrastructure to be able to support electric vehicles in the future. Well, all of those things need to be orchestrated. Okay, and if you think about today, our grid is fragile. So we spend hundreds of billions of dollars right now putting in backup systems for the grid in data centers. Hundreds of billions of dollars, and I'm not exaggerating. And the reason is that if the power goes out and the data center goes down, digital infrastructure stops. So we've now created software that allows us to be more resilient, so we can now build less resilient data centers. So in other words, if a data center goes down, another one can pick it up. But no matter what, you have state information from a data standpoint. It's not going to solve everything. So you need to make sure that you can orchestrate to allow yourself to prioritize workload so that I can bring down the things and shed load, throttle as I need in the event of a power constraint, right? Or outage or something else like that. And so being able to now orchestrate those things is what VPS is doing. So that's what we're working with the Autonomy Institute and EdgeX to be able to now create this environment where we can make every one of those components failable. They can be failure zones. Every pin can go down because you've got hundreds and hundreds of pins across every city. Right? Every city is going to have these things on every street corner. So think about what New York would look like. Think about LA. There's so many of these things that are going to be out there. They're going to provide resiliency across each other. But somebody's got to orchestrate that resiliency. So EdgeX is going to be the platform that actually does all of that compute orchestration. Then you've got VPS, which is going to be the power orchestration. So whether it's the source of energy, whether it's the storage of energy in the vaults, whether it's the balancing with other people using it like EV charging stations, to the compute prioritization, to the actual sensor prioritization. If we have a disaster, last thing you want is 5G to go down because the emergency services need a network. So how do you shut everything else down to just keep that up and the compute supporting it? So prioritization of the compute to ensure that you've got the right services up for the period of time when you need them. That means everything else needs to be shut down and throttled. So we do power orchestration when it comes down to prioritization of the load itself. So we've got X amount of source, X amount of storage, X amount of demand, and we can now say the prioritization of that demand will ensure that those priority loads are always going to be up.
Yeah, I mean it's a scale of all of this, Dean, which I think is tremendous, and it's hard to get your head around. You know, just the sheer volume, the infrastructure required. It's so breathtaking. I mean, one of the things that I'm curious on, and I'm sure some people are that are listening to this episode right now, is the limits, right? You know, what limits are there to this autonomous digital infrastructure? How far can it go?
One of the challenges we've got right now is that there's a stigma or I guess misinformation about digital infrastructure is killing the planet. We hear this a lot. Right? And it's like, oh my God, you're consuming all these resources, whether it's energy and water, etc. But it is the core of how the world works. And if you think about it, there's 2 billion people that are going to be coming online in the next 3 years. 2 billion people. And they don't have connectivity. They don't have, think about that. That wave of people coming in to suddenly be introduced to the world via internet connectivity. Remember the satellites we're talking about. Suddenly, sub-Saharan Africa, all the way down to LATAM, to any other place that's really difficult to actually get connectivity to, suddenly is going to have high bandwidth connectivity, and it's going to change their lives. Access to everything is going to suddenly happen. And so we need digital infrastructure to survive. The planet does. We need to do it in a sustainable way. And so at Infrastructure Masons, we're a professional association of individuals that were uniting the builders of the digital age. And that's why at the beginning I said I'm honored to be hanging out with people that have zeros on the end of their portfolio, right? They've been driving like $100 billion worth of projects around there. And you think about the scale that they're going at. These are the big players, right? The biggest tech companies in the world are thinking about this problem on both sides of that. We have to build out this infrastructure because the pandemic showed, first off, we were exposed when it came down to everybody assumed you had to be in the office, and all of a sudden we were not in the office, and digital infrastructure was the only way that the world kept going. Whether it's ordering, groceries to running a Zoom call to anything else, like all of it was going over this digital infrastructure, and then it grew like mad. Right, that year we were supposed to have 44 zettabytes generated last year. We had 64 zettabytes generated in 2020. Okay, so we were supposed to have 175 zettabytes generated every year by 2025. We're now going to have 225 zettabytes, and I think it's going to get even bigger. And that's because everybody has realized that the infrastructure that we've got here is the way that things work. And so, so that's one side, is we need it. The second one is it's going to grow. So we're 2% of the global draw today. For example, again, there's 7 million data centers, right? They draw about 480 terawatt hours of power globally, which ends up working out to be between 2 to 3% of the global energy draw today. This is everything that is outside of the demarcation point here, is that when a bit comes into the internet and everything it takes to process that bit. Okay? Bidirectional, everything else. Anything inside of there is what is digital infrastructure, which is pretty much every device out there that is not going to be a thing or a person or an edge router that's in your house. All those pieces are going to start to now come together, that the demand is going to increase. So the first one is we need it. The second is we need to do it in a sustainable way. And so that's where these big companies and big thinkers are looking at the ways that you can do this as a system. So, for example, there's a lady named Noelle Walsh. She runs all the infrastructure, right, cloud and everything at Microsoft. And we had this iMasons event where we were talking about the pandemic and what they were doing. And this is 1 month in. And she said, we had an unprecedented number we crossed. They turned up 100 megawatts of infrastructure in 2 weeks.
Wow.
And I mean, literally all of us paused, like 100 megawatts in 2 weeks. How do you even do that? So that was across their portfolio, turning up the data centers they've been building in, commissioning and lighting them up, to actually the capacity from all their partners, turning up more capacity and rolling out. They had that much capacity turned up that fast. So the world needs it, and we have to do it sustainably.
My final question to you today, because we've covered so much here, is what's next? And clearly the obvious answer is more data centers, more power, more speed, more, but aside of that, what should we be looking out for? What sort of initiatives are happening? Because, you're doing some fantastic work yourself. What does the ecosystem look like as a whole here, Dean?
Well, I've touched on a few of them. And I think that the number one thing we've got to figure out as a society is how we store energy, because the world doesn't work without power, and that power in consumption is going to increase. And so, how do we make sure that we can have sources of energy that are renewable, and there's plenty of it? If you just capture the sunlight, we could power the planet multiple times over. Just the sun, right? Okay. The problem is we can't store it. So there's going to be huge efforts in energy storage, because it's a necessity, because everything's going to increase. So energy storage, connectivity itself, and then there's these other ones of the Microsoft put out this $1 billion pledge, and also opened up their patents for sustainable innovation. They have $1 billion fund that says we're going to help companies help us get to their carbon goals. And so I think there's going to be lots of creative ideas around how you do sustainable infrastructure. So, storage is one of them. Carbon capture is another massive one. I think another one that might be a little controversial here is that we need to rethink how we generate energy that's still going to be clean, quote unquote, clean. So nuclear energy in the past has been based on, right, military grade decisions. So we created plutonium, right, and uranium to be able to now create these, because it can weaponize them. But thorium and other nuclear ways of generating energy that's not impactful in that way are the new innovations that are coming out. So that's tied to the energy storage, generation and energy storage. And I think the final one here is that if you take the next 5 years, this is the Wild West when it comes down to edge. But, your cities are all going to change. And what I say is that there's a project called Uber Air that when I was at Uber that was really incredible. The ability to now have these people drones, not just drones as delivering packages and other things, but imagine my transport to be able to get from my house in Saratoga, California to San Francisco when I worked at Uber. I had to drive my car to the train station, take an hour ride up to the train station, walk over to the office. So it was 2 hours door to door each way. I can do that in 15 minutes now when I can say, I go over and jump in an Uber Air, and it goes up, over, and down in the city. So suddenly you're going to be able to now increase the amount of people in a city because of this new transportation that's going to be extremely efficient, right, and consistent. Suddenly you can triple the population within a city during the workday. And then they're all going to go back. So suddenly people can live in remote areas, have good quality of life, and still work in the city. And they don't need to drive cars.
That's the dream, isn't it? I suppose for a lot of people, especially after the pandemic, right? Having their own space and being out there. Dean, it's been some fantastic insights today. Honestly, it's been really eye-opening. Just the sheer scale of all of this, and your passion comes through so clearly. No wonder you're well thought of in this space. It's been a real pleasure. Where can people go out and find a little bit more on VPS, a little bit more on the work that you're doing? Anywhere that they should look online, Dean?
Yeah, you can take a look at virtualpowersystems.com to see what we're doing to disrupt when it comes down to the data center industry, orchestration of power. And then imasons.org. So if you're interested in digital infrastructure, just imasons.org. And let's say you're not in this industry, we actually have scholarships we're giving out because we have a talent shortage and we need more people. And this edge and all the growth is, we need, there's hundreds of thousands of jobs that are available. And especially during the pandemic right now, being part of digital infrastructure, you can start a new career. So go there, check it out, send emails. So dean@imasons.org. Happy to hear any other ideas or connect.
All right, fantastic. Dean, thank you so much for coming on to the IoT podcast show today, and we'll speak to you in the future, no doubt, on an upcoming episode.
Excellent. Thanks, Tom. Thanks for having me on.
If you'd like to find out more about the IoT podcast show, as always, subscribe, comment, share, get involved in the discussion. We'd love to hear your thoughts. Your commitment to watching the show and sharing it is really important, and we appreciate every view. Thank you, and until the next time, goodbye.